Today we're continuing to talk about functional groups so we can understand the modifications that can be made to hydrocarbons. Specifically, we're going to talk about naming and drawing alcohols. So when people talk about alcohol, they're actually talking about a very specific alcohol, ethanol. What alcohols are made by is alcohols are formed when you have an oxygen atom that is bonded to both a hydrogen and a carbon. This looks very similar to a hydroxide ion. It's not a hydroxide ion. It's actually called a hydroxyl group. And even though that might seem confusing, like we've thought of OH being a hydroxide group for a very long time, in reality it's something different because this cannot ionize. The carbon-oxygen bond will not allow it, and it's a covalent bond between those which has extended outside of what would otherwise be the polyatomic ion. So that covalent bond there ensures that even though this is an O and an H that looks like it's a hydroxide, it's actually a hydroxyl that has different properties. If anything, it's slightly, not very, but slightly acidic. And these hydroxyl groups contain hydrogen bonds within them. So that means that just like the hydrogen bonds within water, they're very polar. They're also very water soluble, which is why ethanol dissolves so well in water and why we can make drinks out of it. So alcohols can form what we call a homologous series. And actually, pretty much any functional group can do this, but alcohols are one of the most common ones that we talk about with it in terms of. A homologous series is any series of compounds that has the functional group in the same location. So here we see methanol, ethanol, propan-1-ol, and buta-1-ol. Each one of these compounds has a hydroxyl group on carbon 1. And the only difference between each of them is that they're just adding another carbon hydrogen group onto the end each time. Methanol has 1 carbon, ethanol has 2, propanol has 3, butanol has 4. But they all have the hydroxide in the hydroxyl group in the same location. They're always on carbon 1. It doesn't have to be carbon 1 either. You could do a homologous series of propan-2-ol to butan-2-ol to pentan-2-ol. As long as the functional group is in the same and in the same location, it's a homologous series. And you can do this with carbonic acids, we're going to see in a minute. You can also do this with halogenated hydrocarbons just as easily. When we are naming alcohols, just like when we have multiple bonds, this is effectively a functional group, so the alcohol will go at the end of the parent chain's name. We give priority to the alcohol over the other stuff that we've studied before. So if you have a double bond and you have a hydroxyl group, you would prioritize giving the lowest number carbon to the hydroxyl group. If there's more than one location, just like with other functional groups, we'll indicate with a number which one the hydroxyl is on. So you don't have to do this for methanol or ethanol because there's only one location. It has to be on carbon 1, but you would have to do it on ethan 1,1-diol because now there's 2 ethanol groups. Are they both on carbon 1 or is one carbon 1 and carbon 2? You need to indicate that. Same thing if you have any propanols. Is it propan-1-ol or propan-2-ol? And then if there's more than one hydroxyl group, we will include the di or the tri or the tetra in front as a prefix to indicate how many of those are present in the molecule.